Hi everybody! I miss you so much. Um, and if you don't miss me, you don't have to watch this video. But if it's helpful, here comes the video. So this video is going to be about reflecting functions. And the last video that I made was about translating, which just means sliding things up and down or right or left. Reflecting functions means we're going to take something and we're going to flip it over. Take it, we're going to flip it over either right and left over the y-axis or up and down over the x-axis. Okay, so that's what we're going to talk about today. And we're going to start, we got to pick a parent function. So the parent function I picked this time was a quadratic, so x squared. And that's what you'll see graphed right here. Y equals x squared. There it is. And now that's a parent function. Now I'm going to pick one of its babies, one of its translated or transformed functions, and I'm going to pick the function where I shift it left 2 units and down 3 units. Now remember, the reason I know that happens is I joke that originally we started with x squared, right? Well, instead of just x squared, we added 2 inside there and then squared it. Remember, whatever you do on the inside of the x, it goes the opposite direction you think right and left. Right and left, opposite direction, because the goofy way to remember that is just your x is wrong. That's why they're your x. Either they were always wrong and driving you nuts, so you had to kick them to the curb, or they kicked you to the curb, which is so wrong. So the x is just wrong. Either way. So even though it says positive 2, it's shifted it left 2. And the good news is the y is right. Why? Well, because the y is right. I mean, I do know, but it's a long story we're not going to go into right now. So it actually shifts that down 3, which is great. So this is the new function that I'm going to deal with. It is a transformation of the original parent function, x squared, okay? I don't care about the parent function anymore. I'm just going to deal with this f of x function because I don't want to talk about sliding this time. I want to talk about reflecting. So I'm going to pick one that's already slid somewhere, and we're going to figure out how to reflect it. And first, we're going to talk about how to reflect it over the y-axis, okay? So I'm going to try and take this thing and flip it over here, right? This is the y-axis. So I'm going to take this function and I want to take the mirror image and it's going to go over here. So when we think about, here's 1 point, right? This point is -2, -3. I want to flip that over here. Well, where's it going to be? Well, it's still going to be down -3, but suddenly it's going to be at +2. So to go from -2 to +2, the only thing that's going to change is the x, the positive or negative sign of the x. And that's going to happen with all these points. So to flip it over the y-axis, all we do is we change what originally was x, we're going to change it to -x. And that's the only thing we're going to change. And we're going to go boom. Look how cute it is. She's so cute. And see how each of these points just flipped over. So originally there was a point right here. Let's see if we can find one. Hey, do what I say. So there was a point here, negative. Well, let me see if I can find a whole number one to make it easier to see. Of course not. Oh wait, what's this? This is pretty close to -4, 1. And that reflected way over here to +4. Whoops. +4, 1. See? And this point here, which was 0, 1, reflected over the y-axis is still 0, 1 because the y value isn't going to change, just the x value is going to change. So when we think about, okay, so what did we do to the whole function to get from this red f function to this dotted g function? How did we get there? What did we do to the equation? Well, we took f and we changed the regular old x to -x. So the formula for that the way we talk about that is we say, okay, to reflect over the y-axis, the way we write that formula is we say, okay, the new one, this new function, the g of x, which I'm now going to color blue, is the old function f, the red one, when we change it to negative. Okay? So to reflect over the y-axis, the new function, all we do is change the sign of the x on the old function. To get the new one, change the sign of x. That's it. Okay? Okay? Okay. All right, so now let's try another one. What if we don't want to reflect over the x-axis? Let me get rid of these guys. What if I want to go back to that original f of x, this guy up here, and I don't want to flip it over the y-axis. I want to flip it over the x-axis this time. We'll see. Hang on, I might need to pause and get my charger. Okay, now we're plugged in. Hopefully battery won't die. Okay, so if we're going to reflect over the y-axis this time, nope, we already did, didn't we? Sorry. We want to reflect over the x-axis this time. So we want this guy to flip up, right? We don't want this guy to flip over. We don't want the x value to change. We want the y value to change. So if we change it, let's try, before we put the negative on the inside, what if we just put the negative on the outside? Did it work? I mean, that's good. It's flipped down, but it's not reflected over this. It's reflected over that point, but we want it up here, right? So it's not quite there. And so we need to change something else. We don't want it down 3, right? We want it up 3 from the y-axis. Sorry, from the x-axis. So what if we change that -3 to a +3? Okay, let me take that guy out, put this guy in. Hey, hey, hey. So that flipped it down, that negative flipped it down, and the +3 on the outside moved it up. Ta-da! We did it. We did it. Lois Semos. We did it. So we reflected it over the x-axis. But how do we do that again? Let's think about this for the same. Let's think about this. We stuck a negative on the outside, and then we changed the sign of this 3 that was out front. Originally, it was negative. We go back to the original question. Get rid of that. The original question is way up here. Originally, it was negative. Now we made it positive. Okay? Which basically means what we did was we changed the sign of this part and this part, right? Which is the same as taking this whole original function and changing the sign. We made this negative a positive, and we made this positive out here a negative out here. And when you change the sign of a whole bunch of stuff, you can put a negative out in front and put parentheses on it. And watch, it's the same thing. This black equation and this green dotted equation are the same, the same, the same, the same, the same, the same. They are the same. So when we think through, okay, so how do we reflect a function over the x-axis, right? Over this axis right here. Well, what we're going to do to reflect over the x-axis is we're going to take the original function f of x and stick a negative out front of it. And let me just to prove to you, right? Originally, we called that function, that red function, we called it f of x, and it was red up here. So let me prove it to you. My new function, which I'm calling h of x now, right? My new function is just the negative version. So take that off, watch. Negative f of x, which is the same as the thing I just said a second ago, which was the same as that thing, right? Those are all the same. These 3 are all the same. Okay? So bottom line, bottom line with all of this, and I'm going to close some of these things real quick. To reflect over the x-axis, we take a function and we change all the signs of the y value. Most of the time we call the y value f of x. So to reflect over the x, we change the y's, right? To reflect over the y, we change the x. Okay, that's the bottom line here. To reflect over the y, we change the sign of the x. To reflect over the x, we change the sign of the y. All right, let me show you both of those again. Okay. Hopefully this is helpful and not making things worse. You never know, but let me know what I can do to help you. I miss you guys, and I hope to connect with you sometime soon on the live office hours that I have Monday through Friday at 11 a.m. I'll be on Zoom. Every once in a while it might get canceled because I have to go to some meeting or something. But other than that, I want to be there and I want to be available at a consistent time for you guys. So I've been 11 a.m. Monday through Friday. Hope to see you soon. Okay, bye.